kind of portfolio allocation, and I think that's hard. Friedberg, explain AlphaFold, please.
Okay, let's explain. Give me 2 minutes I'll explain proteins and then the importance of proteins and then AlphaFold. So the numbers to remember are 4, 3, and 20. There are 4 nucleic acids that make up your DNA. We all learned this in high school biology. Sets of 3, A, C, T, and G combinations define an amino acid. There are 20 amino acids. And a protein is a string of amino acids. So in your body, in every cell, there are these organelles. They make proteins by reading the DNA, taking a copy of it, and turning it into amino acid chains. And that's what we kind of call proteins. But what's interesting is when you make a chain of amino acids, so there's 20 of them that you could put in each point in the chain, it doesn't come out as a long chain. What happens is those amino acids, the whole thing collapses, and it turns into a very specific shape. And the shape of that protein is what defines its function. So pretty much every biological function across all life is undertaken by proteins doing something. Some proteins, like hemoglobin in our red blood cells, has a very specific little pocket where oxygen molecules stick into the pocket, and then it moves the oxygen from your lungs to your cells. It's a pretty amazing protein to exist, and it specifically is shaped to do that exact function. There are other proteins that can, for example, rip apart other molecules, break a molecular bond. There are other proteins, for example, that can take nitrogen out of the atmosphere and put it into plants' cells that the plants can then use to grow. There's an incredible a set of potential on the nanoscale of what you can do with proteins, and we see that in life, and we're just shocked and awed and amazed by it every day. But in order to figure out how to create proteins that do specific things, you have to know how do those amino acids turn into the shape that the protein ultimately takes, and that's what's called protein folding. And so the hard thing is, why is this important? It's important because we can easily read DNA, and therefore we can figure out what amino acid sequence is being made to define that protein. But what we don't know really well is what is the shape of that protein, and therefore how does it undertake the function that we see it taking in biology. And if you think about the reverse of this, if you have a function you want to undertake in biology, you can design a protein to do that function for you. For example, bind to a specific point on a cancer cell, or take carbon out of the atmosphere, or pretty much anything else your mind can kind of imagine on the nanoscale. Proteins can be designed to do. The challenge is, how do you write the code, which is the DNA, to make the protein that does that thing? Well, we don't know how the code turns into the shape. And that's what the folding problem is. So the folding problem, there's a data set, and the data set is what's the three-dimensional shape of a protein, and then what's the DNA code that defines the amino acid sequence that makes that protein. And how do you figure out how to predict the shape of the protein from the amino acid sequence? It has been an impossibility. And again, if you think about this chain of amino acids, they each have little electrical spaces, and the way that they bind to each other, it's very complicated. You can't just deterministically define it. We don't have that level of understanding on a quantum scale. So what AlphaFold has done is they have now been able to predict from a sequence of amino acids what the protein shape will ultimately become by learning from a database of hundreds of thousands of structural protein shapes that have been defined through really, really, really difficult scanning microscopes and other techniques to really try and scan a protein on a microscopic scale, and then looking at the DNA sequence and figuring out, okay, what's the relationship? And the accuracy of their predictive model now is within the range of error of the microscopes that are being used to actually scan and measure those proteins. So that's incredible, because now theoretically you could come up with a design for a protein, and you could actually build that protein by writing the amino acid sequence, and that protein can do any number of things you want to do. And this has been a difficult problem that's been intractable by humanity, and we've been challenged by it for decades. For this machine learning breakthrough to kind of be realized in literally less than 3 years. I mean, these guys were at a score of 40 last year, and this year they're at like nearly 90. Which is incredible. Yeah. And so now, we can now predict what the shape will be from the DNA sequence, and And this is going to unlock this ability. Everyone's now going to take their model, if they license it or whatever they do with it, or people are going to go learn using the same techniques that DeepMind used. But it just means that it's possible. And then scientists will go away and they'll say, you know what, I want to do this particular thing on a microscopic scale. Let me design in three-dimensional space a protein to do that thing. Okay, now let me go figure out how to make that protein by writing the DNA code, which is really easy if you can use this algorithm to solve that for you. And it is literally dollars and pennies to make proteins. We can write DNA on a computer. We can get printed DNA sent to us in 48 hours in a FedEx envelope for a DNA printing facility. We can put it in a microbe, and we can get that microbe to make the protein for us in a day. The lab cost, any high school biology class can do this now. So by being able to actually figure out what DNA to write, based on the objective function of what do we want the protein to do, it's going to unlock this universe of things we can do in medicine, in environmental science. We can do things like break apart PET plastics. We can do things like fixing nitrogen from the atmosphere and getting rid of fertilizer plants. We can create all sorts of new, food solutions, health solutions, environmental solutions.
Any chance you can make a pizza that doesn't have carbohydrates? Because that's what I'm thinking about here. Is there a way we can make a healthy pasta or pizza or something like that? But in all seriousness, what do you think the early wins will be out of this technology? And is this a theoretical win that will benefit from in 20 years? Or is this a serious breakthrough that we're going to benefit from in the near term, like
no, I think
1 to 5 years?
Both are true. This is an incredibly important advancement in machine learning. But the reality is that, Google will still have to spend, and DeepMind will have to spend a lot of time refining it. And then they have some really big ethical challenges ahead of it. How do you expose this technology to whom and under what conditions? And it's the same situation that OpenAI has with GPT-3. Although a lot of people, I think, the scale of the computer science challenge maybe was a bigger win in GPT-3 because it was a much more open space. And I think this is a much more specific sort of almost expert system in a way. But the downstream commercial implications of this are just enormous. And so just think about this. Like, this is where you gotta love companies like Google, the fact that they exist, because from, PageRank in 1999 to CPC ads in 2003 and 4, we have AlphaFold in 2020. And that, to me, that's just
This is
bananas.
an argument against breaking up tech, because only a tech company with this amount of resource knowledge can then go spend $1 billion on DeepMind over the past decade.
Alphabet's burning $4 to $5 billion a year on their quote-unquote other bets line. And people give them a lot of shit for it. But, you hit any one of these things and it's $100 billion payday. Look at YouTube. YouTube's easily $100 billion payday on $1 billion bet, $1.6 billion.
Oh, no, that's a $250 to $500 billion company.
Applied Semantics, a lot of people miss this, but Applied Semantics was a $100 million bet. And that's the entirety of AdSense initially.
Android,
right?
Chrome.
Android.
Right.
And
is this the first commercial application of DeepMind? Because until now, they've had AlphaZero. It's been
so there was a period of time. A lot of people. I don't know if. Let me just think about this for a second. Because AlphaZero was really good. I want to be careful about this, but I do think that
to not disclose.
No, but I do think it was disclosed that they've used DeepMind to improve ads quality and to improve YouTube viewing. And as a result of that, you get the number of hours per day of the average user on YouTube to double or triple. Ad revenue goes by 3x. And I think in one quarter, Google was able to generate something like an incremental 15 billion annualized revenue from DeepMind's algorithm.
And you know what that DeepMind actually did on YouTube? It sent everybody to the alt-right and InfoWars and Ben Shapiro. Congratulations. Be careful when you send people's minds with artificial intelligence. Maybe you just argued to break them up.
Yeah. But I understand, Sacks, that it's being used broadly across the products at Google in now in a much more careful way, is my understanding. And I'm a big ally of Alphabet. I'm a big fan, and I love. And I used to work there, and I'm very close to people there. So
who used to be on the board and was the major backer of that company, DeepMind?
Founders Fund.
Elon Musk too, and he begged them to not sell to Google because I think
$400 million exit was a steal
with
for
40
Google.
or 50 scientists. I think.
Yeah, absolute steal.
No, Elon has publicly said that he thinks DeepMind is like the greatest threat to. Well, he thinks AI is the greatest threat to humanity, and of the people working on AI, DeepMind is the furthest along and therefore most dangerous.
He tried to stop. He told me straight up, like when he's been very public about this since, that he he said, I'll give you an unlimited amount of money to not sell to Google. He's friends with Larry Page too. But he said, don't sell. I want you to be independent. I want you to keep working on this. But he said that when he saw the AI there become aware that it was an AI, that was when he was like, wait a second.
No, wait. DeepMind is not AlphaFold or AlphaZero is not self-aware.
He felt it was becoming self-aware, that it knew what it was. I don't know if that was just Elon, just sort of.
No, it's not. It's not self-aware. So I mean, I've watched.
Amazing.
The amazing things that DeepMind has released prior to this were games, right? They had this chess AI called AlphaZero, which rapidly became not just the best chess. It not only beat every human in the world, it also beat every chess engine, because computers became more better at chess than humans a long time ago because of their sheer computational power. But AlphaZero plays like a human, but with kind of that same computational power. And so that created a whole revolution in chess engines. And then they also did that with a game called Go. They created AlphaGo. And basically every single game that you can think of, DeepMind's created, an alpha version that destroys both humans and computers. But this is the first thing they've publicly announced that seems like it will be available to others eventually, that could have tremendous social impact.
Imagine the government trying to understand this. Can you imagine them being brought before like senators or Congress?
Well, these are the new weapons of mass destruction. I mean, let's be honest. Like if somebody else had AlphaFold, and probably somebody does and just hasn't said, Google actually values transparency, so that's the only reason why we know. Imagine what they could do. As Friedberg said, it's like, the opposite of this is basically to design a specific protein that basically destroys organs, or
there are proteins called prions, which are the scariest thing known in biology, in my opinion. A prion is a protein that it actually finds similar proteins, and based on its shape, it gets those proteins to change, and it becomes like a virus. And prions actually there's an extremely sad series of diseases that are related to prions, where your body expresses a protein in the wrong way. And then that protein itself gets other proteins to change and creates copies of itself, and it spreads. It is a fascinatingly scary biological phenomenon. But there are extremely scary things you can do with the designer protein capabilities.
So basically, you could make a bioweapon that would be similar to what the aliens and Prometheus and aliens were doing, the engineers.
Even much worse. Much worse. This is why I think they're going to spend years before. So this is why, back to that earlier question, it'll be years before this sees the light of day, because they're smart enough to know what they've uncovered. And I think they did the right thing by talking about it, because I think there's a lot of really amazing R&D. But the reality is that Google for the next 20 or 30 years will have layers and layers of oversight, because it's not like you're going to allow a company to enrich uranium in Mountain View without oversight. And this is the equivalent. It's just we're buying time until governments realize that they have to do it.
But let's also remember, the protein data set they trained on is publicly available. Anyone can access this, and with the a catch up in machine learning capability to DeepMind infrastructure wise, theoretically someone could I think it's an inevitability that in the next 24 months someone else will replicate this.
Right now, I think what DeepMind has done is showed that specific techniques of learning can overcome limitations in compute. But to your point, David, like we're accelerating silicon at a fast enough speed where, if you can throw 5, 10, 50, 100, 500 petaops at a problem, you can run, some really, really old version of TensorFlow and probably get to the same answer.
Yeah, I actually think they published, I'm going to find it while you guys are chatting, but they published what the compute needs were on running this. I'll find it in a second and tell you.
Because let me make one sort of slightly dissenting point on the whole WMD thing. I mean, look, obviously who has access to this technology needs to be controlled. We do have to make sure it doesn't get into the hands of bad actors. But the reality is there's plenty of existing WMDs out there that have been around for a long time that bad actors could get their hands on. They could already make extremely dangerous viruses in a lab. They could, take something that's as contagious as smallpox and make it as deadly as Ebola or something like that. And it's these new technologies that provide a way for us to combat those WMDs, because, technology has a tendency to become democratized. Was it 75 years ago, the US was the only country that had an atomic weapon. Now, close to 10 have, nuclear or atomic weapons. And so, these sort of nefarious technologies get democratized anyway, and we really need some of these new technologies and new abilities as a way to combat them. So like last week, we were talking about the ability now to basically print, a vaccine using this mRNA technique within 2 days. You can imagine, if someone tried to use a bioweapon, create a new virus, we could print a vaccine the next day. Those are the kinds of capabilities we're going to need to fight the spread of WMD.
I think you're right. It's just that you then have a law of large numbers problem, meaning, the previous problem before is you had 180, 190, 200 state-sponsored actors. So if you had a 1%, rate of people who are just bad, you're talking about 2 states. Now, when you talk about 5 billion people getting access to code that's basically run in an AWS or GCP instance someplace, and you have a 1%, bad guy rate, all of a sudden that 1% really matters. And I think that's the problem. It's just the law of large numbers, David, applied to very, very small rates of immorality.
But I mean, you can already do very scary things with, recombinant DNA, taking DNA from one organism, putting it in another, and sending that organism out. And, theoretically, you could have designed a virus that would spread throughout humanity and cause a lot of death, right? I mean, there's a lot of this capability
Except that
out there.
People would have found that out, because you can't run these labs and you're not going to get, monkey models or mouse models. It's like there's a trail of breadcrumbs there that is easier to track, wouldn't you agree, than just running an instance and a simulation on GCP, sending it someplace to then have a protein printed that comes in a FedEx envelope to you. And
you have to hire people, as we saw in Iran with, their chief scientist being whacked by whoever accidentally whacked him with 60 people. You need to have the brain power to do this. Once you have the brain power to do it, you can track that brain power. And we had, for the last, I think it's since we even tested nuclear bombs, we've had these special planes flying around the globe looking for the signature of nuclear detonations or any kind of nuclear fallout. And we've been flying those forever. I think biodefense is going to become probably one of the biggest industries on planet Earth starting in the latter half of this century, because you're going to get to a point where digital biology is like a tool, just like software was in the 80s, where suddenly everyone could access it, everyone could use it, everyone could do stuff with it. You have this ubiquity of scary shit happening, hackers everywhere. Wait, hold on, Friedberg. Yeah. Didn't we have that as well, and those same claims about nuclear power, and we were been able to, for 100 years,
look, with nuclear
or close to 100 years,
with nuclear in particular,
make it illegal.
With nuclear in particular, there is a material problem. You have to source and refine material to do something scary. With biology, you don't. You can do this anywhere. You can do it on your desktop at home. And, it's getting easier, cheaper, faster, and you can use software and a printer and, a cheap sequencer and do stuff.
Do we believe that China has this, Friedberg?
Yes.
China, for sure. Yeah, I mean, look, 100%. This is, I think...
Are they ahead of DeepMind or behind
100%, 100%.
So here's the stats that DeepMind put out. It took the equivalent of 100 to 200 GPUs run over a few weeks to build this model.
That is nothing.
I don't care how advanced DeepMind is at this point.
That's nothing.
So, if that's the model, then someone else can replicate that. Someone else will replicate that.
That's what happened to AlphaZero, the DeepMind chess engine. After they proved it, now there's a whole bunch of chess AIs. And
I think we're within 1 year, JCal, of a lot of startups replicating this AlphaFold technique and then using that to go do drug discovery. And you'll see 50 startups getting funded 12 to 18 months from now based on some novel protein idea. And I think that this...
All right, we got to get our beaks wet on this in the ISAs. Everybody go to... This is getting ridiculous. Everybody go to thesyndicate.com/all-in.
But I will
we should create a protein... We should create a protein folding syndicate.
Yeah.
Absolutely. Here it is. Everybody go to thesyndicate.com/all-in. If we do this, I'm collecting the emails now.
No, but I will make my first series of bets less on the application and more on the protection. I think biodefense 30 years from now is going to be so important.
All right. If you want to invest with the best ease,
Is there going to be a protein that prevents Rudy Giuliani from farting?